In this video, we are continuing with the tangent properties of the circles. Now here, the question is two circles of radii 18 centimeter and 8 centimeter touch externally. So we have two circles. One is a bigger one and another is a smaller one. They touch each other externally. The radius of this circle is 18 centimeter and the radius of this circle is 8 centimeter, right? Find the length of the direct common tangent to the two circles. Now, if I join this, this becomes the direct common tangent to the two circles. So, if this is point L, this is point M, then this is the point of contact of this tangent LM and this is another point of contact of this tangent LM. So if I join their centers like this and then drop a perpendicular here like this, if this is P, if this is Q, and if I'm dropping PN as perpendicular to this side, LM I have to find, right? Isn't LM equal to PN? Why? Because then it becomes the rectangle. Because this is 90 degree. This is also 90 degree. Radius and point of line joining the radius and the point of contact is always a perpendicular line. This I have dropped 90 degree. This will also be 90 degree then. Then it means that PMLN becomes a rectangle. And we know that the opposite sides of the rectangle are equal. So if I calculate the length of PN, that will be actually my length of LM, right? So that's how I have to proceed. Now I know that this entire LQ is the radius of the bigger circle. It is 18 centimeter. So entire LQ is 18 centimeter. So I will get this is 18. But this radius of the smaller circle is only 8 centimeters. That means from 18, if I am cutting off this distance 8 centimeter, I will get this distance as 10 centimeter, right? And this I already know is the radius, which is 18. And this is the radius, which is 8. Right? If I consider this right angle triangle, in this hypotenuse is given, this base is also given, so I can calculate Pn. So whatever is my Pn will be my Lm. That's how I have to proceed in this question. So what will I do now? I will write to find, what am I going to find? I am going to find the length of PLM, right? So I will write LQ is equal to 18 centimeters. LQ is equal to 18 centimeters. LN equals to MP is equal to 8 centimeters. LN equal to MP equal to 8 centimeters. Therefore, NQ will be 18 minus 8, which is 10 centimeters. So I got NQ as 10 centimeters. And PQ is equal to 18 plus 8, which is 26 centimeters, right? Now, in right angle triangle, PNQ, I can use the Pythagoras theorem as PQ square is equal to NQ square plus PN square. PQ is 26 whole square. NQ is 10 centimeters. And Pn is something that I have to find. So 26, this becomes 676 minus 100 equal to Pn square. So 576 is equal to Pn square. So your Pn becomes 24 centimeters. You got the Pn. But you know that Pn is equal to Lm. Therefore, length of the common tangent to these two circles is 24 centimeters. Fine? Okay. Now, the similar question we have here. He's saying that two circles of radii 3 centimeter and 8 centimeter have their centers 13 centimeters apart. Okay. So this time they are not touching. So we have two circles like this, and okay, they are not touching. They are 13 centimeters apart. Okay, let's not do this. This is a bigger circle. This is a smaller circle, and their centers are 13 centimeters apart. Find the length of a direct common tangent to these two circles. So this is the direct common tangent. So this is the bigger circle whose radius is 8 centimeter, and this is the smaller circle whose radius is 3 centimeters. So if we join this line like this, and then if we drop a perpendicular here, this entire thing is 8 centimeters. This is 3 centimeters. So 8 minus 3, this part, this becomes 5 centimeters, right? So if this is L, this is M, this is perpendicular, this is also perpendicular. So you have dropped this as perpendicular. So this will also be 90 degree. So you have, let's name this as Q, and this point as R, this point as O. Now you have L, Q, R, M as a rectangle. So if you are able to find this QR, that will be your LM. QR and LM will be same because opposite sides of rectangle are same. Fine. Now how do we proceed to find this QR? We will consider this right angle triangle QOR. In this OR is given because two centers are 13 centimeters apart. This we have calculated 5 centimeters. We can calculate QR. Clear? Okay. So let's write this. How will we write this? We will say that LQ LO is equal to 8 centimeters and MR is equal to 3 centimeters. Therefore, QO is equal to 8 minus 3, which is 5 centimeters, right? Therefore, in right angled triangle OQR, OR square is equal to OQ square plus QR square. Alright, so let's write this. This point is Q. So OR is the distance between the centers, which is given 13 centimeter. OQ we have found 5 centimeters, and QR is something that we are looking for. So 169, if I shift this here, 25 equal to QR square. So 144 is equal to QR square. So 12 is equal to QR, but your QR is equal to LM is equal to 12 centimeter. So you have found the length of the direct common tangent.